Welcome to the Deep Dive, where we unpack the knowledge that truly matters. Today, we're jumping into the World Economic Forum's Top 10 Emerging Technologies report for 2025. This one's done with frontiers. And this isn't just, a list of cool new things. It's really about tech hitting a turning point, that moment where, the science breaks through into real, practical, world-changing potential. So our mission today is to unpack these innovations, really try and grasp their strategic side, and see how they could help us all adapt, maybe even thrive in these, complex times.
Yeah, and what's really compelling here, I think, is how they actually choose these technologies. It's quite rigorous. They're looking at novelty, sure, but also how far along they are and, crucially, their power to, transform things. It's about building strategic foresight, not just predicting, but really understanding how these things could reshape our collective future. We'll see how these, weak signals now could lead to some pretty major societal shifts down the line.
Okay, let's get into it. We've got some really fascinating stuff from this report. It specifically flags technologies that are past the theory stage, right? They've shown they can actually strengthen society. And it looks beyond just what they are to imagine what they could create. They even sketch out some possible futures, which is pretty interesting. And as we go through, you'll start seeing patterns emerge, like combining energy systems with new materials, using biology for health in new ways,
Right.
rethinking industry for sustainability, and building new kinds of trust for our digital world.
But that question, how are they chosen? It's key. The method's solid. It involves nominations from expert networks, like the Global Future Councils. They even use AI to see what's trending in academic papers over, 10 years. Then each tech gets evaluated: novelty, impact, depth. And this ecosystem readiness part is crucial. They look at social factors, tech, environment, economics, politics, the whole picture. So yeah, it's not just some list they dreamed up. It's a very carefully curated peek into tomorrow.
What a peak indeed. Let's start with that first area where energy meets engineering. Some cool stuff at the boundaries of materials and energy. First one. Structural battery composites, SBCs. Okay, so imagine materials that can hold weight, like a structural part, but also store energy.
Right.
Think car body panels, or maybe an airplane's fuselage being the battery, not just holding it.
Massless energy, essentially.
Exactly.
And if you look at the bigger picture, strategically, this isn't just neat engineering. It could be a massive deal for energy independence. I mean, the report points out something like 85% of lithium refining concentrated in just 3 countries.
Wow.
So SBCs offer a way to diversify that, maybe decentralize energy materials. That could really shake up the geopolitics around critical minerals.
And here's where it gets really interesting on the practical side. Just a 10% drop in vehicle weight. That can boost fuel efficiency 6 to 8%.
That's significant.
And for an EV, it could increase range by 70%. 70. Yeah. And it's not just cars. Airbus is looking at this for planes. Potential for 15% better fuel efficiency on a, say, 1,500-kilometer flight.
That's a major step for cleaning up aviation. But, okay, there are always challenges, right? Bringing something this different to scale. You've got technical hurdles, getting high energy density, making sure it's stable long-term, safe, durable, cost-effective, all that. Plus, regulations aren't really set up for materials doing 2 jobs like this yet. But, if the investment happens, this could lead to redesigning whole categories of products, cut energy use, build more resilient stuff.
Okay, from solid power, let's switch to water. Osmotic power systems. This is about generating energy from salinity differences, where fresh water meets salt water.
River mouths, for instance.
Exactly. It's clean, it's renewable, and a big plus, it's steady, not like solar or wind that go up and down.
Yeah, and what's fascinating is this idea isn't new proposed back in 75, I think. Yeah, but recent advances in the membranes, the system designs, that's what's making it viable now. You've got companies like Switch Energy building commercial plants. Salt Power in Denmark is using super salty water. Even Japan's megaton water system pulls energy from desalination plant discharge. Kind of a circular thing.
That's smart. And the potential scale here is pretty mind-blowing. The report suggests it could generate over 5,000 terawatt-hours a year.
Which is, what, like a fifth of global electricity needs?
Almost, yeah. Nearly a fifth.
Wow.
And it's not just power. It could help make purified water, maybe recover valuable stuff like lithium or nitrogen from the water too.
The main blockers right now are, well, technical and economic. Things like the membranes getting fouled up, the costs are still a bit high,
Sure.
though performance is getting better. But imagine utilities combining this with wind, solar, hydro, creating much more adaptable energy grids.
Yeah, a more stable mix. Okay, staying with energy, advanced nuclear tech, we're seeing a real comeback, or maybe a new wave of innovation here, driven by rising energy demand EVs, AI data centers, plus decarbonization goals.
Right.
So this includes things like Generation 30 reactors safer, more efficient, and then Generation the 5.
Yeah, Gen the Fourth is pushing boundaries, using different coolants like molten metals or gases.
So they can run hotter, lower pressure.
Exactly. Potentially simpler designs, maybe lower costs down the road. And a key part of this is small modular reactors, SMRs.
Right, the factory-built ones.
Yeah, maybe a third the size of traditional reactors.
Wow.
Much more flexible for placing them. You avoid those huge custom design costs.
Places like China and Russia already have some running.
They do. It shows they're pretty far along in development.
And countries are putting serious money into this. South Korea gets a third of its power from nuclear already. The UAE is investing, what, $163 billion by 2050? Aiming for half their electricity from nuclear and renewables?
It's a major global commitment. It's not just talk. Strategically, advanced nuclear offers that clean, reliable baseline power. Plus, you can site them more flexibly. And things like gas-cooled reactors. They could provide the high heat needed for industries like steel or cement. That's about 15% of global CO2, a really tough sector to clean up.
Interesting angle.
And way out there, the ultimate goal is fusion, right? High confidence, that'll mature in, say, 1 or 2 decades.
Still feels a way off, but closer than it used to.
Definitely. But there are challenges now. Big upfront costs, supply chains need building out, and interestingly, a 25% drop in nuclear engineering grads since 2012. That points to a potential skills gap.
Yeah, that's a worry.
Plus, public trust, cybersecurity, those are always crucial for nuclear, needs proactive work.
Okay, let's shift gears. From powering the world to, well, enhancing us. Biotechnology for health. This section really looks at, the future of humanity, advanced health, nutrition. Big stuff. Let's start with engineered living therapeutics, ELTs. So these are like advanced probiotics,
Right.
microbes, cells, fungi, genetically engineered to make therapeutics, drugs, hormones inside your body, on demand.
Yeah, think of them as tiny medicine factories living inside you. And the breakthrough potential here is huge. They could get around problems with normal meds. Making the drug right in the body could skip all those expensive purification steps. That's like 70% of the cost for some complex biopharma drugs.
70%.
Wow. Plus, it means a steady, stable supply for chronic conditions. Think diabetes. Better adherence, potentially.
And companies are already doing this. Chariot, Bioscience, Aurealis, NEC, in clinical trials.
They are. And safety is obviously a huge focus, making sure these engineered microbes don't grow uncontrollably. They're working on biological off switches.
Right, you need that.
But think about the shift this implies for drug delivery. ELTs could mean decentralized treatments, maybe in a capsule, maybe even embedded in food.
Wow.
It changes chronic disease management from, taking pills or injections now and then to continuous care. Imagine linking that with wearables, AI, getting real-time monitoring, optimizing the bacteria for your specific needs.
That's truly personalized medicine.
Exactly. But the regulations are still catching up, which is, a necessary step for wide use.
Okay, next up. GLP-1s for neurodegenerative disease. Now, most people know GLP-1s for type 2 diabetes or maybe obesity treatment.
Right, those weight loss drugs.
Yeah, but now they're being seriously looked at for things like Alzheimer's and Parkinson's. Early research looks promising for neuroprotection.
The key thing seems to be that these drugs can cross the blood-brain barrier.
Okay.
And once they're in the brain, studies suggest they reduce inflammation, help clear out those toxic proteins linked to these diseases. They might even help brain cells live longer, regulate energy better, maybe improve cognition or motor function. It's a new angle.
And the potential impact, over 55 million people have dementia worldwide.
It's staggering.
If these drugs work for neurodegenerative conditions, the market could hit like $55 billion by 2031.
Huge market.
And think of the reduction in costs, emotional, financial for caregiving. It could be massive.
But, of course, big challenges remain. You need rigorous clinical trials, long-term proof.
Definitely.
Safety is key, especially weight loss in frail patients. That needs careful monitoring. And the cost. These drugs are expensive. Access is a real issue that needs policy solutions.
Sure.
But the potential,
Yeah.
shifting healthcare towards like earlier intervention, actually modifying the disease that could reshape elder care, maybe even help caregivers stay in the workforce longer.
All right, let's move to autonomous biochemical sensing. So these are devices that continuously track specific biochemicals, disease markers, environmental changes.
All without anyone needing to step in.
Right. Wireless, self-powered, often.
And the real leap here is from single-use tests, like remember all those COVID tests?
Oh, yeah.
From that to continuous monitoring, the wearable glucose sensor is the big success story so far. That really showed proof of concept for personalized health tech.
And now, thanks to better materials, nanotech, wireless,
Yeah.
these sensors are coming for other targets.
Like what?
Things like wearable sensors for inflammation that can reset themselves, devices for continuous female hormone tracking.
That could be huge for fertility, menopause care,
Yeah.
getting real-time data.
Exactly.
Stepping back, think about the bigger picture. These could totally change early warning systems. Environmental monitoring could go from taking samples now and then to real-time pollutant detection.
Instant alerts.
Yeah. Food safety, continuous checks, not just batch testing, detecting toxins way faster, more sensitively.
Wow.
And healthcare. Diagnostics moving into homes, remote areas. Still challenges, though.
Yeah.
Sensor lifespan, stability, especially if they use biological parts, and ethical stuff, particularly with genetically engineered biosensors.
Got it. Okay, last one in this biotech section. Nanozymes. These are lab-made nanomaterials that act like enzymes.
Artificial enzymes, basically.
Yeah, they're catalysts like natural enzymes, but potentially more stable, cheaper to make, easier to synthesize.
And their versatility is really key. They can work in conditions where natural enzymes would just break down, hot, acidic, whatever.
Tough little things.
Exactly. R&D investment is booming, and we're seeing promising results in cancer treatment, neurodegenerative diseases.
Oh, like targeted drug delivery.
Yeah, or helping reduce oxidative stress.
And beyond health. Environmental uses water purification. That's a big one.
Sustainable water treatment.
Right. Food industry detecting contaminants quickly in packaged meat, for example.
Yeah.
Industrial chemistry cleaner, greener catalysts.
The market potential reflects this, valued at, $5 billion in 2024? Projected near $58 billion by 2034?
That's massive growth.
But, the hurdles. Making them as selective as natural enzymes is still tough. Safety, especially in biological systems, needs careful study. And the regulations are still developing. That always affects how quickly things get to market. But the potential is there for much more precise catalysis. Plus, integrating AI for designing them, that could really blur the lines between scientific fields.
Okay, that takes us to our third big theme. Reimagining industry and connected systems. Looking at evolving ecosystems, tech vulnerabilities, digital realities. How it all comes together. Let's kick off with green nitrogen fixation. So, nitrogen fixation turning air nitrogen into ammonia. Crucial for fertilizers, right? Supports half the world's food production.
It's absolutely fundamental.
But the standard method, Haber-Bosch, uses like 2% of global energy. And tons of CO2 emissions.
Yeah, it's incredibly energy intensive. So the whole point of green nitrogen fixation is to slash that carbon footprint. People are looking at using engineered bacteria, enzymes, electrochemistry.
Using just air, water, and renewable electricity.
That's the dream. A huge shift from a century-old, dirty process to something sustainable.
And companies are on this. Jupiter Ionics, Amobia.
Yeah, they're exploring these alternatives.
And this could mean decentralized production, right? Making ammonia locally with wind or solar.
Exactly. Cuts transport energy, costs. Plus, ammonia itself is being looked at as a potential zero-carbon fuel for ships.
Really? Marine fuel.
Yeah, could power maybe 30% of global shipping fuel by 2050. So beyond just cutting carbon, the strategic impact is massive. It could reshape farming supply chains, reduce transport risks, stabilize fertilizer prices. Huge for food security.
Makes sense.
Challenges, though. Commercial viability for some methods isn't proven yet. Some rely on lithium, creating another dependency. And ammonia is toxic, needs careful handling.
Right, practicalities.
Yeah.
Okay, next, collaborative sensing. This is about connecting all those sensors already out there, homes, cars, workplaces.
The Internet of Things idea, but smarter.
Yeah, linking them with AI to get deeper insights, better capabilities.
And the power here is moving beyond just isolated data. Imagine traffic lights that talk to each other, adjust timing automatically to ease congestion.
That'd be nice.
Or an autonomous car knowing about a speeding car way ahead because other sensors picked it up. Beyond line-of-sight awareness.
Oh, okay.
The FCC adopting that 5.9 gigahertz band for CV2X, vehicle-to-everything tech, that's a big step towards enabling this.
And the applications are everywhere. Better city traffic flow, Autonomous mapping in mines, tracking storms, coordinating drone swarms.
Environmental monitoring, precision agriculture.
Yeah, it could really change how cities run, how organizations use data.
Big picture. Collaborative sensing could transform urban systems, emergency response. In transport, V2X shows huge potential for preventing accidents, like 59% to 77% crash avoidance in some studies.
Wow, that's impressive.
And truck platooning, enabled by this, cuts fuel use 5–10%.
Real savings.
But challenges exist. Powering all these sensors, keeping them connected reliably, data security, privacy, massive concerns.
Absolutely.
And global 5G access is still patchy, only about 55%. That limits how widespread this can be for now.
Okay, finally, generative watermarking. This is about putting invisible markers in AI-generated content, text, images, audio, video.
To prove it's AI-made or trace where it came from.
Both, yeah. It's becoming crucial because AI stuff's getting really hard to tell apart from human work.
And we're seeing a real surge in watermarking tech to fight misinformation, protect copyright, deal with academic cheating.
Like Google's Synthety for text. Meta's Video Seal.
Exactly. And the big AI companies are already building this in, partly because regulators are pushing for it.
But the implication here is bigger than just compliance.
Oh, right.
It feels like the start of a whole governance system for digital content. This could transform media, creative industries, maybe even legal and financial systems if watermarked content becomes like accepted evidence for IP disputes.
Huge potential, but also big challenges. Simple edits can sometimes break the watermark detection. People will try to remove them, forge them.
The cat and mouse game.
Always. And there's the risk of misuse, like falsely labeling real stuff as AI made.
Ooh, yeah. That's tricky.
So you need watermarks that are really tough, tamper-resistant, work across different formats, and it only really works if everyone adopts it. Uneven adoption weakens the whole system.
It needs industry buy-in.
And regulatory alignment. China already requires watermarking. The EU is figuring out its approach. It needs to be coordinated.
So, wrapping this all up,
Yeah.
what does it mean for you listening? This deep dive into the 2025 emerging tech really highlights how innovation isn't isolated, is it?
Not at all.
These breakthroughs, structural batteries, changing how we build, green ammonia, transforming farming, AI watermarking, building digital trust, they're all signals of bigger shifts happening globally.
Yeah, and looking at the bigger picture, these aren't just technologies in a vacuum. They're catalysts. Catalysts for rethinking how we tackle huge global challenges. And the report really stresses that getting these innovations to scale, it takes more than just brilliant tech.
Right.
You need the whole ecosystem to develop social acceptance, tech capability, environmental sustainability, economic sense, supportive regulations. It all has to work together.
Building those bridges from lab to real-world impact. And it's worth remembering, the WF has a track record here, right? They flagged CRISPR gene editing back in 2015.
That was early.
And mRNA vaccine platforms in 2017, way before COVID hit.
Yeah, these reports often catch things early. They're not just snapshots. They're like waypoints on the innovation journey.
Absolutely. And this work, fundamentally, it's a call to action. It's a catalyst for the kind of collaboration we need to help these technologies actually deliver on their promise for a better future. So knowing what's potentially coming, what part of your life, or maybe your industry, or even just your local community, what feels most ripe for transformation by these technologies? What might you rethink or build differently now that you know these innovations are moving from just promise to potential impact? Something to think about.